What up, Year 9 gang? How's it going? So I know you got a test on nth term coming up and sequences on your test. So I thought I'd just give you a quick review sheet that you can practice on in your own time, alright? So, if it's a test about sequences, the most important thing we have to know in this test, the basics, you should at least know how to find the nth term of a sequence. The nth term basically refers to the formula of a sequence. And with the formula, you can find any term in a sequence. So let's have a look at this first example. I have a sequence, 3, 7, 11, 15, 19. And someone asks, find the nth term. What I do is you should always draw a table. And here, it's just a number sequence, I'll put n and t. N stands for the order of terms. T stands for the term. And let's fill it out. The first term is 3. The second term is 7. The third term is 11. The fourth term is 15. And the fifth term is 19. What we're going to do first, guys, is find the term-to-term sequence. Step 1. The term-to-term sequence. Basically, that's the jump from term to term. And that's going to be plus 4. If it's plus 4, we're going to multiply by 4. So 1 multiplied by 4 is 4. And we have to subtract 1 to get to 3. So basically, our nth term is going to be n multiplied by 4 minus 1. Or a better way of writing that is n times 4 is just 4n minus 1. And that's our answer. That's our nth term. And using our nth term, we can find the 75th term. All we do is replace n with 75. So 4 times 75 minus 1. And that is... oh my gosh, where's my calculator? Oh, damn. Let's go. 4 times 75 minus 1 is 299. For the 89th term, all I do is I replace n with 89. $355. The 89th term is 355. Let me give you another example. We'll do an example going backwards. 7, 5, 3, 1. So let's find the nth term here. I'll draw my table out. Nice and big, nice and clear. Nt. The first term is 7. The second term is 5. The third term is 3. The fourth term is 1. So when you do your table, guys, don't make it cramped like this. Make it nice and spacious like this so you can do your arrows. So we know the term-to-term jump is minus 2. So if the term-to-term is minus 2, we're going to multiply by minus 2. 1 times by minus 2 is minus 2. And to get from minus 2 to 7, we add 9. So our nth term is minus 2n add 9. Now someone said, yo, find the fifth term. All I do is replace n with 5. 2 times 5 is negative 2 times 5 is negative 10. Plus 9 is negative 1. And the fifth term is negative 1. So over here, guys, you can do a bit of practice in your own time, alright? So let's move on to the next concept. Next set of questions. Check if a term is in a sequence. So the sequence 2, 5, 8, 11, 14, 17. And the question is asking, is 98 a term in the sequence? So first things first, the question is not asking for the 98th term. The question is asking, does 98 appear in the sequence? Well, it seems like we're jumping by 3 every time, so let's keep going, and hopefully we'll hit 98. The problem with this method, guys, it's super damn slow. So there's another way, and the first thing we're going to do is we're going to find the nth term. Let's draw our table out as usual, nice and spacious. N and t. The first term is 2. The second term is 5. The third term is 8. The fourth term is 11. Well, the term-to-term rule is adding 3 every time. So I'll choose 2 this time. We're gonna multiply by 3. 2 times 3 is 6, minus 1. So our nth term is n multiplied by 3 minus 1. Now, to do this problem, we're not going to replace n with 98. That will make us find the 98th term. We're checking if 98 is in the sequence. What we're going to do is we're going to set this equation equal to 98. And we're going to find n. We can do this, guys, by drawing a little function machine. So our equation is something times 3 minus 1 is 98. Let's draw a function machine. So we have n is being multiplied by 3, then it's being subtracted by 1, and 98 is coming out. And we just work backwards. We get 98. The opposite of subtracting 1 is adding 1. The opposite of timesing by 3 is dividing by 3. Let's have a look. 98 plus 1 is 99. Divide 3 is 33. N is 33. So we can say 98 is the 33rd term. So it is in the sequence. So we say yes. It's the 33rd number in the sequence. So let's check if 55 is in the sequence. So we get our nth term, n times 3 minus 1, and we set it equal to 55. And then we go backwards. So we start with our function machine. So n is being multiplied by 3, then it's being subtracted by 1, and 55 is coming out. And we work backwards. 55, we plus 1, then we divide by 3. Let's have a look. 55 plus 1 is 56. 56 divided by 3, I'm feeling lazy, is 18.6. So basically, 55 is the 18.6th term. Can you have 0.6th of a term? No. It's like babies. You can have one baby, you can have 2 babies, you can't have 1.6 babies. It's impossible. So the answer is no. 55 is not in the sequence because you can't have a 0.6 of a term. So the answer is no. Let's check this one. 2n minus 3 is 197 in the sequence. Well, luckily for us in this problem, guys, they've given us the nth term. So we don't have to find the nth term. All we do is get 2n minus 3, and we set it equal to 197. So let's draw our function machine. We start with n. What's happening to n? It's being multiplied by 2, then it's being subtracted by 1, and then 197 is coming out. We just work backwards. 197, we plus 1, and we divide by 3. And let's see what comes out. 197 plus 1 divided by 3 is 66. It's the 66. It's the 66th term. 197 is the 66th term. So yes. So guys, here's some questions you can do on your own, and you can always get back to me when you're done. Alright guys, before we start this page, I just want to let you know that all the sequences we've done so far are called arithmetic sequences. Arithmetic sequences are just sequences that go up by the same amount each time. So it's plus 3, plus 3, plus 3. This is called an arithmetic sequence. Here's another example of an arithmetic sequence. 8, 6, 4, 2. We're going down by 2 by the same every time. This is called an arithmetic sequences. There are some sequences which are multiplication sequences like this. The sequence here is 1 times 3. 3 times 3 makes 9. 9 times 3 makes 27. A sequence that multiplies is called geometric. So what we've been focusing mostly on so far is arithmetic sequences. Just a quick FYI. So let's get started with these problems here. So now there's just some kind of pictures. Here's a sequence of patterns made from white and gray tiles. Pattern 1, pattern 2, and pattern 3, pattern 4. Draw pattern number 4. Well, this one just seems pretty obvious, guys. Just look for the pattern here. There's 2 white tiles, 3 white tiles, 4 white tiles. There'll be 5 white tiles in pattern 4. There's 1 black tile, 2 black tiles, 3 black tiles. There'll be 4 black tiles on either side here. So easy marks. Just draw it out like that. Now the question is asking, work out the total number of tiles to make pattern number 7. So for pattern number 7, one sec. So one way I could do this problem, guys, is to just keep drawing the pattern. So I have pattern 4, I could draw pattern 5, I could draw pattern 6, and I could draw pattern 7. That's like a really long time. So what we can do is we can just make our nth term. So we'll have our, we're going up in patterns, so patterns, and we're counting the number of tiles. So what you're counting is always on the bottom. So pattern 1 has 4 tiles, pattern 2 has 7 tiles, pattern 3 has 10 tiles, pattern 4 has 13 tiles. So our term to term rule we see is +3. This is our term to term. Don't forget the vocabulary. So I'll make our nth term, and I'll make it based on 3. So if it's +3, it has to be times by 3. So 3 times 3 makes 9, plus 1 is 10. So it's going to be p times 3 plus 1. We're trying to find the number of tiles for pattern 7. So all I'm going to do is replace p with 7. 7 times 3 plus 1 is equal to 22. And guys, it doesn't really matter what you name these columns. It could be n and t still. But I just called it pattern and tiles. It really doesn't matter. Next problem. Kyle says there are 4 white tiles in pattern 3. So there will be 8 white tiles in pattern 6. All right, well, we could do this. We could organize our information by drawing another table. So we have our patterns, and this time we're only looking at the white tiles. So pattern 1 has 2 white tiles. Pattern 2 has 3 white tiles. Pattern 3 has 4 white tiles. Pattern 4 has 5 white tiles. And he's asking to find out how many white tiles in pattern 6. Well, what do we notice, guys? The number of white tiles is always 1 more than the pattern number. 3 and 2, 4 and 3, 5 and 4. So in the pattern number 6, there should be 7 white tiles. So Kyle is wrong because he's saying there's 8 white tiles in pattern 6, but we've just found out there are 7 white tiles in pattern 6. Final problem. Is there a pattern with 122 tiles? This is very similar to our last problem. We're not trying to find the number of tiles in the 112th pattern. We're checking if there is a pattern with 112 tiles. So we're gonna get our equation, p times 3 plus 1, and we're gonna set it equal to 112. And we'll just draw a function machine. P is being multiplied by 3, then being added by 1, and 112 is coming out. And we're going to work backwards. 112 minus 1 divided by 3. Let's have a look. 112 minus 1 divided by 3. Ooh, 37. So yes, there is a pattern of 112 tiles. It is the 37th pattern. So you can try these problems below here, guys. A, B, and C. Yo, what up, guys? Next problem is finding the nth term of fraction sequences. This looks really hard, but it's not really, guys. Let's have a look at the sequence. 9 11ths, 13 16ths, 17 21ths, and 21 26ths. And we got to find the nth term. What you got to realize is that the numerators have their own sequence, and the denominators have their own sequence. Do you notice the sequence of the numerators? It's going up by 4 every time. So the next term will be 25. And what's the denominator sequence? It's going up by +5 every time. +5 to get to 26. So +5 to get to 31. So basically, the numerator has its own sequence and the denominator has its own sequence. So we're gonna have to find two separate nth terms, one for the numerator and one for the denominator. So let's draw out the first one for the numerator. So we have our n and our t, and we'll call this the numerator sequence. So the first term is 9, the second term is 13, the third term is 17, the fourth term is 21. Well, the term-to-term rule is plus 4, so we can times by 4. 1 times by 4 is 4, plus 5 makes 9. So our first nth term is n times 4 plus 5. Then let's make a sequence of our denominators now. So we have our n and our t. The first denominator is 11, the second denominator is 16, the third is 21, the fourth is 26. We know the term-to-term rule is plus 5. So we multiply by 5. 1 multiplied by 5 is 5, plus 6 is 11. So it's going to be n times 5 plus 6. So we have two sequences. So our numerator sequence is n times 4 plus 5, and our denominator sequence is n times 5 plus 6. And that's our answer, guys. It's just realizing that the numerators have their own sequence, and the denominators have their own sequences. To make this neater, of course, you can write n times 4 is basically just 4n plus 5, and then 5n plus 6. And then someone says find the 20th term. All we do is replace n with 20. So instead of 4 times n, we're going to do 4 times 20 plus 5, and over 5 times 20 plus 6. 4 times 20 is 80, plus 5 is 85. 5 times 20 is 100, plus 6 is 116. And that's the 20th term. So here we go, guys. Feel free to do some of these problems by yourself. Guys, some challenging problems now, but I promise you, if you draw your tables out, follow the steps, you're going to be totally fine, because it'll make perfect sense. All right, the third term in an arithmetic sequence is 14, and the seventh term is 26. What is the nth term and what is the 15th term? So, in our an arithmetic sequence, we only know what the third term is and the seventh term is, and we got to find the nth term. Well, let's draw a little table out. N and T. And in this problem, we only know the third term and the seventh term. The third term is 14. The seventh term is 26. Let's fill the rest of the table out. Let's draw some jump partitions. So we know it's an arithmetic sequence. The jump is the same amount every single time. So if the jump from, if this jump from 3 to 4 is y, this jump's also going to be y. It's arithmetic, the jump's the same every time. And we know the total jump from 14 to 26 is 12. I'll put that down here. The total jump from 14 to 26 is 12. And we can split that into 4 equal jumps. We can divide that by 4, which is equal to 3. So we know each jump is just 3. So 14 plus 3 is 17. 17 plus 3 is 20. 20 plus 3 is 23. And 23 plus 3 is 26. We can work backwards as well. 14 minus 3 is 11. 11 minus 3 is 8. Now we can find our nth term. So the jump between each term, the term-to-term rule is plus 3, so it's going to be multiplied by 3. So we can use this number, we can choose 2. 2 times 3 is 6, plus 5 is 11. Let's double check here. 1 times 3 is 3, plus 5 is 8. Good. So it's n times 3 plus 5. 15th term, all we're going to do is replace n with 15. So 15 times 3 plus 5. 15 times 3 is 45, plus 5 is 50. That's our answer, and this is our answer here. Next one. The fifth term of an arithmetic sequence is 18. The eighth term is 9. What is the nth term? So same thing. Let's just draw our table out and just fill in the blanks. That's that's the tip. Just draw your table out and fill in what you know. Don't do nothing. Draw your table out. So in this problem, we know the fifth term is 18. The eighth term is 9. I'm going to move this all up a little bit. So from the fifth term to the eighth term, there are how many jumps? 1, 2, 3. And in total, the total jump is going backwards by 9. So we can split -9 into 3 jumps. So -9 split into 3 is -3. So we know the jump from each term is minus by 3. 18 minus 3 is 15. 15 minus 3 is 12. And 12 minus 3 is 9. Perfect! Now we can find our nth term. So we know the term-to-term rule is -3. We can grab any of these numbers. 5 multiplied by -3 is 5 times -3 is -15. And from -15 to 18, from -15 to 0 is 15. From 0 to 18 is 18. So that's a jump of 33 in total. So it's n times -3 plus 33. And to find the 22nd term, all you do is replace n with 22. So 22 times -3 plus 33 is -33. So the nth term is n times -3 plus 33. Or a better way of writing that is -3n plus 33. And the 22nd term is -33. And those are your two answers. All right, gang. Great job. I think I actually have one more problem to show you, all right? So just bear with me. Thanks so much. Okay, guys, final challenge problem. We have a sequence 2, 6, 10, 14. And we got to find out what the first term over 50 is. So we have our sequence, and I notice we're adding 4 every time. So perhaps we can just keep adding 4 until we find the first term over 50. Plus 4, plus 4, plus 4, plus 4. Well, this question is not bad. It's just the first term over 50. But imagine we're doing the first term over 500. We're going to have to keep on adding 4 until we finally find a number which is above 500. That'll take us ages. So we're going to find a strategy. Well, step 1, as usual, you see a sequence, you don't know where to start, just find the nth term, guys. That will put us on the right track. So n and t, the first term is 2, second term is 6, third term is 10, fourth term is 14. To find the nth term, we're going to find the term-to-term rule, which is plus 4. You can grab any of these values. I'll do the third term, and I'm going to times it by 4. 3 times 4 is 12. Minus 2 is 10. Oh. So our nth term is n times 4 minus 2. Then we have to find the first term over 50. So one way we can do this, guys, is let's find out which term gives us exactly 50. So what we do is we can, I'll move this down here, is do n times 4 minus 2 and set our equation equal to 50. We're going to check which term gives us 50. So we're going to use our function machine. N is being multiplied by 4, then subtracted by 2, and 50 is coming out. 50, we're going to add 2, divide by 4, and see what comes out. 50 plus 2 is 52. Divide by 4 is 13. 50 is the 13th term. Well, we're looking for the first term over 50. So the next term after 50 is 54, which is the 14th term. So that's what our answer, guys. The first term over 50 is 54, and that is the 14th term. So all you're going to do, guys, is find out which term gives you exactly 50. So you find your nth term, set it equal to 50, work backwards to find n. And so we know the 13th term is 50, therefore the 14th term must be 54, and that's the first term above 50. So that's our answer. So something very similar to the next question. 23, 20, 17, 14. What is the first negative term? Well, one way is we notice that we're going backwards by 3 every time. So we can keep going backwards by 3 until we become a negative number, which won't take too long in this case. The first negative term is -1. That would be our answer. But let's solve this using a more mathematical method. But yeah, this is one way you could totally answer this. You could just say the answer is -1 and you'll get a few marks. Let's solve this the proper way. Because what happens if our term starts at a really high number? It's going to take us ages to get down to a negative number. What I'm going to do is I'm going to draw my find the nth term again. N and T. The first term is 23. Second term is 20. Third term is 17. Fourth term is 14. This time I noticed that we're going backwards by 3. -3. -3. So it's going to be multiplied by -3. 1 multiplied by -3 is -3. To get from -3 to 23, we add 26. So our nth term is n times by -3 plus 26. And we're trying to find the first negative term. Well, in order to do this, guys, let's find the term which gives us exactly 0. Because once we find a term which gives us exactly 0, the next term will definitely be a negative number. So let's set our nth term equal to 0. So n times -3 plus 26 is equal to 0. Let's show our function machine. N times by -3 plus 26 is 0. Let's go backwards. -26 divide by -3. 0 minus 26 is -26. -26 divided by -3. Oh man, I don't want to use my brain today, bro. And where's my calculator at? Here we go. So 0 minus 26 is -26. And then -26 divided by -3 is 8.6. So now we know the 8.6th term is 0. Problem is, guys, we can't have an 8.6th term. So therefore, the next term afterwards, the 9th term, should give us our first negative term. So we can replace 9 into our nth term. So our nth term was n times -3 plus 26. So we'll place n with 9. 9 times -3 is -27 plus 26 is -1. So yeah, we confirmed our answer. The first negative term is -1, which is the 9th term. Sorry that we didn't have too much space in that problem. So basically, mates, we're trying to find the first negative term. So we're going to find the term which gives us exactly 0. The logic behind that is because once we find the term which gives us 0, the next term after that is surely negative. So we set our nth term, n times 3 plus 26 equal to 0, as we did here. And we use our function machine to go backwards, like we did here. And we went backwards, and we found 0 is the 8.6th term. Therefore, the term right after must be the first negative term, which is the 9th term. And then all I did was I replaced 9 into my nth term, and that came out as -1. So the first negative term is -1. And feel free to bang out some of those questions by yourself. All right, cheers, lads. Good luck for your test, and any questions, just let me know, all right? Cheers.